So, I was saying, there is no need for me to go through to define time. Take your time, understand those definitions. It might come as maybe a test, it might come as a quiz, it might come in the final exam. A question like, what do you understand by the word idealization in mechanics? So, the models that we have developed, they are like a particle, a rigid body, a concentrated force. These, they are not, in reality, you cannot see that particle that we are talking about. For easy analysis or solving that problem, you need to apply this idealization by making certain problems, instead of you consider it as the complete body, you simplified it as a particle. So this is just an example. This is just an example. You can see that there is a rope there and another rope there and another rope there. For you to analyze that thing, it will be easier for you to make this as a particle, where this where you assume that that will be a force and another force, and of course another force. So you make it as a particle where you assume that all these ropes, they meet at the center. That is the particle we are talking about. A concentrated force. This is an example. All of you have seen that before. You would find that the wheel itself, there is contact between the wheel and the rail, maybe from here up to there. There is some contacts there. There is that load that is being applied on the rail. There is that contact between the wheel itself and the rail. But for easy of analysis, it becomes easier for you. You just say it's like a concentrated load or a point load. Those are the models that have made solving those problems easier. Of course, apart from those, you also need to understand what's the difference between mass and weight. What is a load? Most of the problems will be asking you to solve a problem with a given load, with a given weight. So you need to understand what are those. What is a moment? So a moment, a very simple definition of a moment. It is the force that has been applied multiplied by the lever arm. A moment is always where the force has been applied, the magnitude of that force times the distance to where that force has been applied. And that distance is always supposed to be perpendicular to where the force has been applied. Don't forget, this is an example of a moment.
Sir, please come again on the issue of the moment. We didn't hear you clearly.
I was saying, a moment, simple definition, it is the magnitude of the force multiplied by the perpendicular distance to where that force has been applied. In other words, a moment, it's a force that is making a rigid body to rotate. This is a force that is making a body to rotate clockwise or counterclockwise, depending on where that force has been applied. So, if I can give you this example, the way we analyze a moment, we have got a load applied on this member, A, B. The distance from A to where the 600 pound has been exerted, it is 2 feet. Then the distance from B to where the 600 pound has been exerted, it is 8 feet. The total span between A and B is 10 feet. So, find the moment about A. When you are looking for the moment about A, you forget about B. B, the support at B does not exist. Now, from your reasoning, get your leg or your arm, stretch your arm, then apply some load on your palm. Where is your arm going to go? Is it going to go up or down?
It's going down.
It's going down. So that is exactly what a moment does. So when you apply a force on your arm, your muscles will try by all means to resist your arm from going down. So the force that your muscles are applying for your arm to be horizontal, that is the moment. So for you to calculate the moment that your muscles are now applying, it will be where you have applied that load and the distance from your joint, which is your shoulder, to where that load has been applied. So for this example, it will be 600 times 2. That is the moment at A. Is it the moment, is it clockwise or counterclockwise?
It's clockwise.
How do you mean it's clockwise? Explain why it's clockwise.
So the moment is clockwise because the plank will rotate in the clockwise direction to the left, and it will be going.
Thank you. Thank you. So today in this class we are going to agree. Then here I was just trying to show you some concepts and principles. What is a coplanar force? What is a concurrent force? So here this sketch is just showing you are going to have a coplanar and a non-coplanar. Coplanar simply means the planar. It is being applied on the same plane. If it is x and y, it is x and y. If it is in 3D, it can be in x, y, and z. It can be in x and z. It can be in z and y. What is a couple? A couple is more like a moment. It's just the same as a moment, except that when you talk about a couple, you are talking about two equal forces being applied oppositely, but applying the same sense of action. I can give a practical example. Those who are privileged of driving vehicles. When you are driving a vehicle, you want to turn to your right. You use your left to push the wheel right, whilst the right hand is still also pushing down. That is what we call a couple. But except that they are always two equal and opposite forces. That is clear, right? So here you have got F and another F. Whatever is happening here, it is creating some sort of rotation. This force is creating some rotation, and at the same time this other force is also creating the rotation. Note that a couple, always these forces, they are supposed to be equal. Then it's a couple. If this force is not the same as this one, then it is not a couple. So when you want to determine the moment of a couple, there is no need of you calculating the moment about this point, and again you come and do the moment about this point. No, you just consider, you just calculate that moment at a specific force, which is, if you want to calculate your moment, it will be the force times the lever arm, which is the distance in between those two forces. All of us, we know what a vector is. All of us, we know what a scalar is. There are a number of ways of representing a vector. So you can use any of these. Or, and note that to represent a vector, you always have to show. Yeah, so I was saying, keep in mind that the complete representation of the vector must be able to determine its magnitude, one, direction, line of action, and the point. Yeah, so I was emphasizing to say the complete representation of a vector, you need to calculate the magnitude, the point where that vector is being applied, the direction, which is the angle, and the line of action. Now, our statics, for us to start solving those problems, we need to understand the 6 fundamental principles. These were developed through experiments, not just assumptions. No, they did some experiments to confirm these principles. The first one, I'm sure all of us, you know parallelogram law. All of us, we know it. And we know what a parallelogram is. The principle of transmissibility. The principle of transmissibility, it is just indicating that if you apply a force like the way the force has been applied here, then you decide to change, instead of pulling the track from, pull it from front, you would want now to push it to add the force from behind, which is this. If you have applied the same force, this force and this force, for as long as it is applied along the same line of application, you are going to have the same result. This is what it means by principle of transmissibility. Also here, this is just a body. It has been applied at point A with the same force F. It will give you a reaction which will be equal to when you apply the force at any point, even here, for as long as it is along the line of application. Same force, the same magnitude of the force, and you are applying it on the same line of application. I mean, all of us, we are familiar with the Newton's three fundamental laws. The first one, the second one, and the third one. So I won't go through that, but it might come in the exam test just to ask you what is the implication of the first law of Sir Newton's on a body that has been applied with 4 different forces. Then from your understanding, you explain what normally happens when you apply a force to that body. What will happen? The second law and the third law, which normally talks about the gravitational force. Units. Here we are just going to agree what type of units are you going to be using. So sometimes you might see a question, it is in SI units, or sometimes you might find it is in US units. the foot, the pound, the mass. If you'd want to convert from US to SI, general procedure for analysis. We are going to pause here for 3 minutes, then we continue.